This video goes over simplifying rational expressions. A rational expression is an expression that has a polynomial in the numerator and in the denominator. For example, something like this is a rational expression. So you should be able to evaluate the following. You should be able to evaluate rational expressions, substituting in given values for the variables. Let's try an example here using first x is 2 and second x is equal to -1. So here I'm going to substitute in 2 for x. Then, remembering my rules of BEDMAS, I'm going to evaluate the top and evaluate the bottom. And then I'm going to do the same thing with -1, just for practice. Substituting in -1 for my variable. And then I'm going to evaluate the top, no problem, and the bottom. So this is a big uh-oh. We can't have a 0 on the bottom. So that means that x can't equal -1. And in rational expressions, we call these restrictions. So values that the variables cannot take on. So let's take a look at some examples here. So the first thing we're going to do is simplify the following rational expressions, and we can do that using our exponent rules. So simplifying a here, I'm going to do my number divided by the number, which leaves me with 7. X to the 5 divided by x to the 3 leaves me with x squared. I'm dividing powers with the same base, so I'm going to subtract the exponents. I haven't done anything with y. There's nothing on the denominator, so I'm left with a y. The next one, I'm going to start the same way. So 20 divided by 10 is 2. X cubed divided by x to the 1, I'm going to subtract the exponents, leaving me with x squared. Y squared over y to the 5, again, I'm going to subtract the exponents, leaving me with y to the -3. I always want to write my answer with positive exponents, so I'm going to put y to the -3 on the bottom. This is also going to give me a restriction here that y cannot equal 0. Let's try the next one. First thing I'm going to do is divide by numbers. 12 and 36, that is the same as 1/3. Next, I'm going to look at my x's. I've got x squared divided by x8. I'm going to subtract the exponents, which gives me x to the -6. And finally, I'm going to look at the y's. So y cubed divided by y squared leaves me with y. I'm going to make sure I write my answer with positive exponents by putting that -6 onto the denominator. And then I'm going to state my restrictions. Because x is on the bottom, x can't equal 0. Our last one in this set, I'm going to start off with my numbers. So 4 over -8 is the same as -1/2. Then I'm going to look at my x's. I have 1x on the top, 1x on the bottom. So no x's left. Y to the 4 divided by y to the 6 is y to the -2. Z to the 5 divided by z to the 8 is z to the -3. And no a's on top divided by a squared on the bottom would be a to the -2. Rewriting my answer with positive exponents, y squared, z cubed, a squared, and then stating my restrictions. So y, z, and a all can't equal 0, just as we saw up here when we substituted in -1. So that's one way to simplify rational expressions, by dividing and using our power rules to simplify. We can also simplify by factoring. So let's start with the first one, 6 over 9. We can reduce that to 2/3, no problem. And there are no restrictions because there are no variables. Let's look at the second example. I'm going to check and see if I can factor the numerator. I can common factor out a 2. Then I'm going to do the same thing on the bottom. Check and see if I can factor. X squared minus 4 is a difference of squares, so I can factor that as x minus 2, x plus 2, and then what I realize is that I can actually cancel out x plus 2 from the top and from the bottom because they're the same. That leaves me with a simplified rational expression of 2 over x minus 2. And then the last thing that I'm going to do is state my restrictions. And I always state my restrictions going back to the beginning before I did any canceling. So in this case, there are 2 values that x can't take on, and those 2 values are 2 and minus 2, and those come from the zeros of the denominator, or what I got when I factored that expression. If I substitute in either of those values, I will get 0 on the denominator, and my expression won't exist. Let's try another one. So I'm going to start off by looking at the numerator, seeing if I can factor it. I can common factor again here by taking out 3x squared, which simplifies to 3x squared times 2x plus 5. And then I'm going to see what I can do on the bottom. Here it looks like I can start off by common factoring. And then I've got a tricky trinomial that I'm going to factor. So I'll leave my numerator alone for now. And then I can factor my denominator as x minus 2 times 2x plus 5. And then I notice that I've got 2x plus 5 on the top, 2x plus 5 on the bottom, which gives me my simplified rational expression of 3x squared over x times x minus 2. And then I'm going to state my restrictions. So again, I'm starting here before I've done any canceling. And my 3 values that x can't be are the values that would make the denominator 0. So those values would be 0, 2, and minus 5 over 2. I'm solving for the answer that would make each of those brackets in the denominator 0. Let's do one more example. First thing I'm going to do on the top, just like the previous examples, is I'm going to common factor. To start, 10x plus 25. And then I'm going to common factor the bottom 2 by taking out 4x, which leaves me with 5 minus x. And then I can factor my numerator a little bit further as a simple trinomial. And it's actually a perfect square trinomial, if you recognize that. And now it looks almost the same, but not quite. I have my x and the negative side in the wrong spot. So what I'm going to do on the bottom is actually factor out a negative sign, which is going to make my denominator negative, but is going to flip the signs in my bracket. If you check, if you multiply the bracket by -1, you will get back what you started with here. But now making that adjustment means that I can cancel out that factor from the top and the bottom, leaving me with my simplified expression of 2 times x minus 5 over minus 4x, which I can reduce further as x minus 5 negative over 2x. If I wanted to redistribute the negative, I could write it as 5 minus x over 2x without the brackets. The last thing that I need to do here is state my restrictions, so the values that are going to make the denominator 0. Remember, I'm starting from here where I don't have any canceling done. So my first value is 0 and my second value is 5. Both of those values can't happen because when I substitute into the denominator, I'm going to get a 0 on the denominator, which doesn't exist. Those are two examples of simplifying rational expressions. First, using the exponent rules, and second, using factoring.